Welcome everybody to the April edition of the Northwest Gas Association's monthly webinar series. We're pleased to bring Doug Stake with CarbonQuest to you to talk about distributed carbon capture. We're going to give it a few minutes. We've got a good turnout for our webinar today. We're going to give folks a few minutes to sign in. So just wanted to welcome you and let you know that we'll be back about 5 after 12 or so. Hi, folks. Welcome to the Northwest Gas Association's April edition of our monthly webinar series. We're going to get started here in about 2 or 3 minutes. So we just wanted to give you a heads up. Welcome to the show. Well, good afternoon, everybody. Welcome to the April edition of the Northwest Gas Association's monthly webinar series. This month, we're pleased to bring you a webinar on distributed carbon capture delivered by CarbonQuest. Doug Stake is Senior Vice President of Customer Operations at CarbonQuest. And we're really excited to have Doug here to talk about this technology that's ready to go off the shelf, already being deployed. Really a great technology and one that's homebound. I think for those of you that are familiar with us, we like to feature technologies and information that really come right straight out of our region. And CarbonQuest is headquartered in Spokane Valley, Washington, just east of Spokane and west of Coeur d'Alene, Idaho. So, Doug, we're really glad you're here today. I'm going to go over a few of the rules for the day, and then I'll stop sharing and let you load up while I introduce you. But for our crew on the webinar, I think most of you are familiar with how we operate. We ask you to remain muted throughout the presentation. If I hear background noise, I'll go looking for you and we'll mute you, but we'd appreciate it if you did it yourself. So keep yourselves muted. And then you're familiar with this chat function in Zoom. Please pose questions as Doug is proceeding through his presentation. Please pose your questions in the chat function. I'll be monitoring that chat function. And Doug, for your information, as a question comes up, I'll just interrupt you when you take a breath and pose the question. At the same time, you know, I will also encourage at particular moments throughout your presentation, I will encourage folks to go ahead and type questions that they have in. Our presenters always appreciate the questions. It makes it a little more interactive rather than them staring at a screen with a bunch of black boxes and names. They get to actually answer a few questions. So really be thinking about what questions come to mind and then put them in the chat box. We are recording this session and it'll be posted on our YouTube channel sometime later this afternoon. Feel free to forward that around to folks that you think might find it interesting. In addition, Doug has indicated that the slide deck that he's presenting today, we can make available. You'll just reach out to Judy Adair if you'd like a copy of the slides, and she will forward them to you at that time. We also want to highlight for you our upcoming webinars. We've got an invitation out to One Future. I think most of you are familiar with One Future, which is a methane emissions reduction organization. Several of our members are, several of the Gas Association members participate in One Future. We're going to get an update from them about the progress they're making on reducing methane emissions from the entire value chain of the gas system. And then in June, we have Guidehouse coming to visit with us. This is a fascinating presentation, which I've been privileged to see a couple of times now, but it's trends influencing decarbonization in the West. And they have some really terrific analysis and good information, and we encourage you to participate in both of these upcoming webinars. So Doug, I'm gonna start to introduce you, but first thing I'm gonna do is stop sharing, and so you can load up your deck while I'm talking about you. So there's the stop share. Feel free, Doug, to go ahead and start sharing. So for the rest of our participants here, Doug's an energy professional. He's worked globally in the energy system for 35 years, a pioneer in the world of smart grid technologies, including smart metering and intelligent energy storage. He's currently, as you know, Senior Vice President of Customer Operations at CarbonQuest, focused on this technology that increases decarbonization now, that is actually right now decreasing or increasing decarbonization. He's worked for a couple of other companies over the years past in global roles, including Itron, which is another home-based organization, global company based in Spokane, also Spokane Valley. So Doug's been in this space for quite a long time, and we're excited to hear from you, Doug. So with that, take it away, folks. Enter your questions in the chat, and we'll go from there. Thanks,
Thank you, Dan. Really appreciate it, and happy to be here. So let me see if I can get things to progress here. So what we're going to talk about is the world of distributed resources, and in this regard, as far as tying that to distributed carbon capture. So in lots of cities, buildings are the main culprit of carbon emissions. So being able to distribute resources and capture carbon locally and then manage that is important. And for our customers, especially in New York, they're subject to upcoming penalties. So I'll talk about that in a bit too. So, when we look at some of the key drivers that's going on with decarbonization, and you got governments that are pushing in certain areas as far as, what is their goal for reductions in emissions trading, like in the UK, that's ETS over there. In Canada, they've enacted a price on carbon of 170 Canadian, which I think right now is about 135 US as far as emissions, excess emissions, and the tax on carbon emissions that will be evolving here. The interesting thing with the SEC and corporations that file 10Ks and all their SEC registration, as far as if they're doing carbon capture and receiving a tax break from the 45Q, which is a IRS tax break for carbon sequestration, that's required to be reported in there. And it's for large corporations, they take that very serious. When I was at Itron, we got very serious when it was time to fill out 10K. So, and then looking at local regulations, we see more and more larger cities starting to look at and trying to figure out how they're going to tackle emissions, carbon emissions, and what they're going to do to control that. And then in the EU, dealing with their whole aspect of disclosures and being able to improve just the overall performance of different buildings and devices in the area there. In the corporate world, which one thing I would say, I think 2 years ago, Larry Fink from BlackRock, who writes a very famous letter at the first of the year, one of the things Larry said in there was, if you're a corporation and you don't have an ES&G program, right? So you need to have one, because corporations, they're responsible for reporting on their filings with the SEC. Looking at in global companies as far as what they're doing from reporting on their emissions globally and being able to keep track of that, and people are starting to get serious about no more greenwashing. You have to be able to track and show and demonstrate what are you doing. We see a lot of first movers as far as from a coalition perspective, and a lot of corporations are very focused, and we think those first movers are going to help pull the rest of corporate world into these sort of paths as far as how do you report on what you're doing. When you look at legal actions as far as greenwashing, and then even insurance providers on climate risks and disclosures, what are you doing? What's going on there? It's starting to hit home corporately for a lot of issues out there. When we look at the opportunities in cities and the U.S. building stock, there's quite a bit of properties out there that are hard to decarbonize. It's very difficult to take a 30-story high-rise and that was designed to be electric based for lighting, elevators, maybe some fans for air conditioning, things like that. But to convert that to electric heat is very problematic. And we haven't seen a lot of that in the retrofit space. So in certain areas, and what we look at in market segmentation, there's 336,000 commercial buildings over 25,000 square feet. There's 300,000 industrial buildings that are a potential for this sort of technology. And then looking at the multifamily space, which we think is very favorable in what we're currently deploying in right now in New York City. There's lots of opportunity, and coming up with a way to demonstrate carbon emission reductions for those group of customers is important. This is a tool set that an engineering group called AKF developed in New York City that you can go in and analyze. Where are you as far as what you've reported on your usage in energy and gas? And then they go through and look at, and in New York, they have different metrics for different types of buildings. There's a metric for multifamily buildings. There's a metric for hotels, a metric for commercial properties. And what that is based upon the square footage in a building, it has a factor that says, here's your allocation, here's what you're allowed to emit, And then here's what your limit would be. And then this tool set here says, okay, based upon the emissions factor and what your limit is for the time period from 2024 to 2029. And then your limit decreases in 2030 and then decreases even more in 2035. So it steps down from, a level here. I got to just move the little screen here. It steps down from for this particular account, and this was a university we looked at. Their penalty starting in 2024 is almost $13 million based upon 45,000 tons of carbon emitted, or that's their threshold, but their penalty will be that much. Then look at what occurs in 2030. That penalty moves up to almost 19 million, and then roughly 23 million starting in 2035. And those penalties are substantial enough where it has their attention and they're trying to figure out what is the path forward. And I would say just in general, because this goes in effect next year, most of these buildings are not prepared. And they're really starting to figure out what's going to happen and where things headed. When we look at multifamily buildings or hospitals or commercial buildings, this is an example of a multifamily building where the penalty starting in 2024 is about 700,000. It moves to 1.4 million starting in 2030, and then almost 2 million starting in 2035. So it really has people's attention. I think people are sitting back at the moment saying, are they really going to do this? Is it really going to happen? And so far, it looks like, yes, it's going to happen. And so we expect next year is going to be very busy as people start to look forward and try to figure out what are they going to do from a penalty standpoint. Let me talk a little bit about our process. So it's really kind of 4 steps where we extract CO2 from the flue gas and we basically cool it. And then we run it through what is known as a pressure swing separator, okay, or pressure swing adsorption system. It's really what separates the gases after we cool it, take all the water out, put it into the PSA. It takes the oxygen and nitrogen, allows us to put that back into the chimney where it came from, redirects the CO2 over the final stage where we liquefy that. And that liquefaction of CO2 is 2 steps. You pressurize it up to about 300 psi and you cool it down to about minus 15 Fahrenheit. And then it's stored in a tank. And when that tank's full, we have a truck pull up and we offload it. It takes about an hour to offload it and pick it up and then take it out to one of our partners that are going to utilize it. Currently, we take it out to a concrete block manufacturer out in Brooklyn, and they inject it into their concrete block. And when you inject CO2 into concrete, it transforms into calcium carbonate. So even if in 100 years you were to crush that block, you're not going to emit a bunch of CO2. It's totally utilized and transformed. This is our installation. This is right across from the Lincoln Center. This is a 33-story building owned by the Glenwood Corporation. This is the installation. It took up about 700 square feet within the facility. One of my favorite things, because I've had multiple people tell me I don't understand, there's no room for this stuff. I tend to find room for a lot of things in buildings in New York. There's just a lot of junk that they hold on to. And if you got rid of the junk, then you can make room for equipment. So when we look at the value proposition for these owners, so they get immediate decarbonization solution. Our model is turnkey and it's non-disruptive. We go in and install. We don't require any shutdowns or turn downs or anything to install. We see a payback of about 4 to 6 years. Larger projects, we're seeing 2 to 4 in some of those. Take advantage of tax incentives, the 45Q tax incentive that you can take if you're in a region that doesn't have a tax penalty like New York. You can take advantage of carbon credits. And then also CO2 as a product right now is in short supply. When most CO2 was produced as a byproduct of ethanol or ammonia, and during COVID, a lot of the ethanol production reduced. A lot of the gas companies sold off their ethanol plants, and worldwide, there's an overall shortage for CO2. And so using CO2 in different processes in different regions has a very volatile pricing right now. So we think the pricing is going to hold pretty steady, and we're not commercially produced CO2. We're recovered CO2. So a little bit different. We have trademarked the term sustainable CO2 in our whole operation. When you look at
Doug, let me interrupt just quickly. I don't have a question yet, but I just want to remind the crew, you've already gone through a little bit of the business case, some of the process. If anybody has questions, please feel free to use the chat function to enter those questions. Thanks, Doug, for letting me interrupt.
You bet. You bet. And when you look at the business case, like this is a multifamily high-rise building. So you look at the revenue benefits annually, about 600,000. The operating expense is about 200,000. So that's electricity, maintenance, taxes, insurance, things like that. So the net revenue is about 4 million. The CapEx was about 2 million to put in there. So about a 5-year payback for that. And when you look at, there's the 10-year total over here. And for a lot of our customers in that sort of payback range, that meets their hurdle rate. So, and then when we look at the various users out there that we work with the block manufacturers, and they sell into the building community, which has a whole focus on lower greenhouse gas building products. So it really helps them as far as what they call an LCA that shows how much carbon went into a product to make it. There's a reduction by using this. And there's other emerging markets as far as using CO2 to develop polymers and chemicals. There's geological sequestration where you inject CO2 into basalt rock and it gets transformed into calcium carbonate. And then a very interesting one is liquid fuels. Sustainable aviation fuel looks like an area that we will probably start to partner with. We have one company out in Brooklyn that's developing that, and there's others emerging. So CO2 is a key component for evolving into new market space. It looks very promising.
Doug, let me interject here if I can. Regular attendees of our monthly webinar series will recall it was either last month or the month before, we had Pacific Northwest National Lab here, PNNL, talking about carbon storage in the basalt structures that Doug referenced. And they started the research on this more than a decade ago. And there was a bit of a lull in interest because it was just too expensive. But as Doug has indicated, the interest in finding carbon sequestration solutions has really picked up, and the financial case for it has picked up as well. So the vast basalt deposits that we have in this region across Eastern Washington and Eastern Oregon in particular are really because when, as Doug mentioned, when the CO2 is injected into those formations, it transforms over time to calcium carbonate. It seems like a great opportunity. So there's, even here locally, we've got some good sequestration opportunities if you can't find a way to actually monetize the CO2 itself. Thanks, Doug.
And if you think about calcium carbonate, it's what the cliffs of Dover is built from. And it's also the raw source for making cement. So when you make cement, you heat up calcium carbonate and it frees the CO2. and leaves it as calcium oxide. So there is a circular world around that as well. So this just kind of gives you some of the market size trends that we see as far as utilization and concrete and fuels and aggregates and algae and feed products. There's very interesting opportunity to use bioreactors and feed the algae with CO2 and form animal feed and various food products, where it looks very encouraging from what we've seen. Polymers, one of my favorite polymer stories is to use green concrete, CO2 injected concrete with carbon fiber rebar that was built from fibers that were developed through a process of CO2 and transformation into carbon fiber based products. So I think you guys understand this path, and when we talk about electrification of the grid and consumption of all that by users, I don't think we're having a very honest discussion, right? It's very easy to say, look, we just need to convert to wind and solar, and we'll be in great shape. And one of the things at the building that we're installed in, they use about 5 million kilowatt hours of electricity for lighting and all the things, elevators and just basic building operations. But if you were to take and convert the gas heating that they use and just do a straight conversion from therms to kilowatt hours, and that's really not a fair conversion because gas is much more efficient than just electric-based heating. The result would be you would add 7 million kilowatt hours of electricity to that load. Now, in an area like New York City that uses basically 20% of what the state of California uses in a landmass that's 0.5% of California, that's a big problem. And delivering that in an urban network is even more challenging, just to build the network, the distribution network to deliver that. So I think all this stuff will happen. It's going to occur. New York's got incentives to build 9 gigawatts of wind, 6 gigawatts of solar, and 6 gigawatts of batteries to help with that conversion. But I've been working there for 25 years, and I know the pace, and I can see how that's going to occur. And so we need to figure out what can we do today to help reduce emissions now. So that's what we put together with distributed carbon capture. We got immediate results. It's economically viable. We can deploy it rapidly, and it's common sense for larger buildings. Any questions so far?
Remember to use the chat function to enter your questions in. Good information, Doug. Thank you.
Mm-hmm. So one of the things, and I think all of you are probably working on this as well, is how do you build a credible alternative energy transition story? How do we have, like I like to say, an honest discussion about what it's going to take? It's important to get customers educated. When you look at the industry ecosystem and working with them as far as the path to decarbonization, how to help them in building a viable story, finding leaders and voices that are coming to middle ground, offering a common sense view, and casting a viable path and roadmap for how we're going to get there. Because it's important. It is important. We have to figure out what we're going to do to start driving emissions. I used to have a graph that showed carbon emissions, and people would say, well, hey, carbon's always been changing in the atmosphere. That's true. It's been going from 200 parts per million, 300 parts per million, and vacillated for about 400,000 years. But the last 60 years, it's climbed up to over 400 parts per million. And based upon the science, we have got to figure out how to reduce and continue to focus on that while maintaining the energy sources that we need to keep keep things moving forward. So there's policy battles happening now. It's time to engage and help drive those policies into a fashion that allows for a migration. Finding ways to demonstrate that carbon technology options work and can deliver, immediate and cost-effective pathways, and continue to find ways to lead the conversation, engage in just the overall market here. Sorry about that. Just a little bit about us, what's going on. We've had several folks pick up what we're up to and write about this. And tonight on CBS National News, there's a little short clip about what we're doing. They were over a couple of weeks ago and filmed what we're up to, and they'll be on there if you happen to catch CBS News this evening. A little bit about us. We're a group of guys that have built 5 different companies together over the past 35 years. Not all of us have worked in the same 5 companies. Most of us have worked in 3 different companies over time. And we tend to tackle problems that are hard on the front end. We built a battery storage business. We introduced battery storage almost 13 years ago, and people looked at us like we were crazy. And now battery storage is a key component to building the grid of the future. We think distributed carbon capture is the same sort of technology that's evolving and getting people comfortable with it. How do you deploy it? How do you utilize it? And when you're a pioneer, you're used to walking around with arrows stuck in your back, and we're all really comfortable with that space and know where we're headed and look forward to moving forward. So from that, love to just open up the discussion. You can't tell me I stumped the crowd, Dan.
Sorry, I was on mute. I was very eloquent there for about 30 seconds. Can you talk a little bit more about the project that you have deployed in Manhattan, kind of its nature, what it looks like a little more, and other projects that you may be doing or are in the works? I mean, one of the things that you said is it's non-disruptive to the building. So if you've got a 35-story building, how much space does it take? Where does it go? How do you install it without disconnecting stuff? What's the actual physical layout look like? I think that might be interesting.
So we occupy 700 square feet in the basement of that building, and the third, what they call subcellar 2, third floor down. We moved all the equipment. That building happens to have a car elevator. It's at the same level where they park all the cars. So we were able to find 700 square feet, built a room around that. And it was a section where the breaching, which is the duct that leads from the boilers to the chimney, comes through. We tap that. We pull the exhaust in, the portion that we need to drive the business case, into our process. We cool it, compress it, liquefy it, and then when we're full, pump it up out to the street. So that has worked out very well. There was plenty of electricity. That project uses about 100 kilowatts of power to operate. It's fundamentally compressors and heat exchangers is what the process involves as far as physical components, and of course the pressure swing absorption system. We have 5 more projects in the works. Here in our office today, we're doing the final factory acceptance test for the next system that will ship out on the 5th of May. Going through that and doing the testing, and we have the 3rd system is halfway through construction at our plant. What we do is we put the systems together as they will be set in the building. We design the layout and test everything and make sure we got all the piping and all the interconnections and electrical and control and all that put together. And we'll run that and test it through various phases. And then once we're happy with that it's operating at the level that we need it to operate, we'll tear it all apart, put it on a truck, ship it out to New York, and go through the process of rigging and deliver that into some space in a building and put it back together and tie it into the boiler flue exhaust, into the electrical system. We'll tie it into various ventilation systems. So we got ventilation in the room, tie it into how we're going to put the gas back out, how we're going to put the CO2 out, the piping of all that, get it all put together, button it up, throw the switch, and we're off and running. So we really don't disrupt anything as far as a process and a build, other than the parking guys get a little annoyed with us because we keep asking them to move some cars so we get stuff through, but that's really the biggest inconvenience.
So I got a couple questions here. I think you've answered this second one. If not, you kind of answered it already. This first one, what is the concentration of the CO2 stream needed and the power consumption that you use? So I think I heard you say 100 kilowatt hours for power consumption. And on the concentration of the CO2 stream, you're using flue gas, aren't you? And what?
Yep.
So
And that flue gas, that's important because we go through and look at the boilers and we make sure that the boilers are well tuned. So those boilers deliver between 8% and 9% CO2 in a dry measurement to our system. So the front end, we take about 8 to 9% CO2, and our power level is 100 kW. And there's a emissions factor in New York that we use to say how much carbon did we create or emit to do this process. We're about 70% efficient. And as the grid gets greener, that emissions factor goes down lower. So we've got modeling of what New York's projecting that their emission factors will be. And in 2035, it looks very promising as far as if they move forward with a lot of these emissions. New York's a bit like the Northwest. A lot of folks don't understand that, but they get about 25% of their electricity through Hydro-Quebec up in Canada.
Mm-hmm. Mm-hmm. Next question is relates to the dimensions. 700 square feet, is that inside or outside footprint?
What was the last part?
Inside? So is it 700 square feet inside the walls? You build a building around it. So what's the actual, or is that
guess what?
outside?
We build the walls out of bricks that have CO2 injected in them. So your standard concrete block. So the 700 square feet includes that wall. Okay.
So it's an outside dimension, it sounds like.
Yep. Mm-hmm.
Maybe a couple other questions while others are typing things in here, Doug. One is there, so what I heard you say is the business case for this basically is the carbon tax in New York City, that you're saving the buildings money on that, which because they're not paying as much tax as they would absent your carbon capture and utilization scheme. Are there similar, is there a similar kind of setup here in Washington State or in British Columbia or in Oregon, given the carbon trading mechanisms that are being discussed? I mean, so British Columbia has a big carbon tax and I think a cap and trade. Are there opportunities here in the Northwest where this would make sense, given now that we have carbon pricing here?
British Columbia, with that national tax that's coming on, the business case looks pretty good. In Washington and the 100 biggest emitters, we just met with Department of Environmental Protection, DEP, and their can't remember if they're DEP or DEQ, but they were listening. They're very careful about what they say. All of those agencies are careful about how they approach this. So we think there's a good opportunity for helping Washington lower the emissions. But the other thing too is we believe we can trade what we capture in some of these global trading platforms as well. So if we can't get local reduction from some sort of state initiative or whatever, we believe that we can trade those carbon reduction in these global emission platforms that are out there.
Do you have a general sense of the size of building, or I would say maybe the emissions, process emissions that are required to kind of make this work? So it wouldn't work for a house, for instance, my home, it wouldn't work for.
I think a good
but
metric is to look at and say, if a building uses 250,000 therms a year and above, it's a good candidate. Anything below,
Okay.
it's the business case is a little tougher.
And how about light industrial applications? What's that? Have you guys explored there?
Yes, and especially in central Washington in the food processing industry, there is a lot of continuous operation where they use, boiler-based platforms for heating and drying and operations. And we think it's very encouraging from what we've seen there. And we've looked at a couple of opportunities where then we would also tie together the CO2 production with a sustainable aviation fuel.
Interesting. You talk about food processing. We've got a lot of paper plants in the region too. Are they too big, or is there an application there? I'm just spitballing now. I don't know the answer, but well, I think about that.
A lot of this equipment scales. So too big is, I'm not sure. We've talking to a couple of steam plants and we're talking to a paper mill, local paper mill here in Spokane, for the exact same thing. So being able to capture and there's lots of opportunity, and we think that we've got a path to help them reduce as well.
Okay, I have a rephrasing of the area required question. It turns out Todd really wasn't asking about the footprint of the room. What he was asking is, can it be installed outside? Can your equipment be installed outside in a parking lot rather than inside in a mechanical room?
Yep. No, we've looked at those installations. There's a couple of things where we may just put a cover on a certain device or whatever, but most of this equipment, remember, is basically compressors and vacuum pumps and surge tanks, and all of that stuff is very easy to put outside and just ensure that they're not going to be disrupted by weather.
And is temperature an issue? Does it affect efficiencies, equipment efficiencies, if it's hot or cold, for instance?
Hot means you got to put more cooling in. Cool means use less, and it's very helpful. So, but you just size the various components that are doing the cooling so that they can handle the ambient temperature, but it's not a big impact on our number.
Yeah, so that's interesting in a state like New York, which can get cold. When those boilers are really firing, it gets more efficient. Is that what I'm hearing you say?
Yeah.
Yeah. Okay. Any other questions for Doug? Take a minute or two to